Welcome back, students. This is the Q&A session 12 from the playlist of current electricity. The topic is EMF and internal resistance of a cell, and the question for this session is written on this board, and this is the figure which was provided along with this question. The question is, the figure shows the variation of potential difference versus current across a combination of three identical cells in series. So we have to find the EMF and the internal resistance of each cell. So there are four options here, and we have to find the correct one. So we have already studied that V is equal to E minus IR, where E is the EMF value of a cell, V is the potential difference across a cell, I is the current, and R is the internal resistance of a cell. So from this equation, that is V is equal to E minus IR, and from the figure which is given on this, which is given along with this question, we can see here that when the current here is 0, then the value of V is equal to 6. That is, when I is equal to 0, V is equal to 6 volt. And when I is equal to 0, then V will be equal to E. That is, the potential difference across the cell will be equal to the EMF value of it. So that now here in this question, there are three identical cells which are connected in series. That is, the combination is something like this. Let us say these are the three cells and they are connected like this, means they are connected in series. Now in the series combination, the potential difference across the ends of the combination will be equal to the potential difference will be equal to the sum of the potential difference across each cell. That is, if for example, let us say the potential difference across this cell, say number 1 is V1, the potential difference across this cell is say V2, and the potential difference across this cell say is V3, then the total potential difference V will be equal to V1 plus V2 plus V3. Now here when the current is 0, V is equal to E. That is, the total EMF value of this combination will be also equal to 6 volt. That is, the total EMF value of this series combination is equal to E. Now this series combination consists of three identical cells which are connected in series. So the EMF value, that is the E value of each cell, will be equal to 6 volt divided by 3, which is equal to 12, which is equal to 2 volts. Since these three cells are connected in series, therefore the total EMF value will be equal to the EMF value across the cell 1 plus the EMF value across the cell 2 plus the EMF value across the cell 3. And since E is equal to 6 and all these three cells are identical, therefore I can just write E1, E2 will also, the value of E2 will also be equal to E1, and the value of E3 will also be equal to E1. So E1 will be equal to, which is equal to E2, which is equal to E3, which is equal to 2 volts. Okay? So the EMF value of each cell is equal to 2 volt. Now we have to find the internal resistance. Now from this formula, that is V is equal to E minus IR, I can write that R is equal to E minus V upon I. So from here, from this figure, we can see that when the current is 1 ampere, the value of V is equal to 0. That is, when I is equal to 1 ampere, V is equal to 0. So what I will be doing is, and the EMF value of each cell is 2 volt. So the internal resistance R will be equal to 2 minus V divided by 1. That is, when the current is 1 ampere, then the value of V is 0. Okay? So what I have done is, I have substituted the value of V as 0 and the value of the current is 1. The EMF value of each cell is equal to 2. Therefore, the internal resistance of each cell, that is R, will be equal to 2 ohms. So here the correct option is A, that is, the EMF value of each cell is 2 volt and the internal resistance of each cell is 2 ohms. So I hope that you have understood the solution of this question. Here the most important thing is that we have to use this formula, that is V is equal to E minus IR, where E is the EMF value, V is the potential difference across each cell, I is the current and R is the internal resistance. So thank you very much for joining this session, and in the next session I will be taking up a different type of question from the same chapter, that is current electricity. So till then, have a nice day. Bye.